resistance in series and parallel, and also the supply, AC supply, connection of AC supply to it. Okay, and I am recording this session and I will share with you the link of this video so that you can again go and check. Okay, so what you need to do today, that first you need to make this circuit. Okay, so just like first your, and I told you that resistance will depend upon your ID. Let us suppose your ID is 202322052. Okay, so your R1 value is 2, R2 value is this one 5, second last, R3 is third last, but it is 0, so we will take 2. Okay, now we will connect these three resistors as shown in figure. For this we go to TinkerCAD. Okay, activities, you will find activity, or you can go to create circuit. Okay, now after creating a circle, first we need a breadboard to make a connection. And for breadboard, you know that once this point is, one point is connected to all these 5 6 point, okay, 5 point, if something is connected here, so it means if anything is put it here at all the point F G H I J, they are connected to each other. Okay, similarly to, as you move your cursor, you will see that this, it is showing that this point all are connected. Similarly in this positive and in this negative. So first we will take this first circuit, and the value of first circuit is 2, as we discuss in this file, 2. Okay, second circuit, the value of second circuit is 5.
Doctor,
Third resistance 2. Yes,
uh, all we must do like that, or we use our
your
final three
ID,
numbers?
your final three number, not these number. This is for the example
Ah,
according to your ID number. Okay, so this is R1. So for first what you will do, you will connect R1 to this. Okay, now R1 is connected to this. If you closely look this, so what is happening, R1 and R2 are in parallel. So now you have to need to connect R2 also from this line. So you take R2 and connect it here. You can connect at any of these point. Okay, now R2 and R3 are series. What is meant by series? Means when start point of R3 should be connected to the end point of the R2. So end point is this. So whenever you connect any of this point, it will be connected. So I am connecting this. Okay, so R2 and R3, these are in series, and this R1 is in parallel with R2. Now what happened, R3 will also be in parallel with this if this endpoint and this endpoint are common. What endpoint of R1 and endpoint of R3? For this we will take a line, green line, we connect this at this point. Okay, to look it fine, what we can do, we can make a line proper. Now what will happen, circuit is complete. Start point of R1 and R2 and R3 are in series. Okay, so if you want to check the total equivalent resistance, what you can do, either this is the endpoint, or endpoint you can connect to the this positive terminal, so it will be closely to each other. So I will take another cable. This cable in experimental work, what you can do, you can take it as a jumper wire. Generally jumper wire is called, when you came in lab, we will show you that is. Now you can see the positive supply going here, R1, R2, R2, R3 are in series, and these are connecting and going to at this point. Sorry, this point is not right, this point. Okay, else this will be okay. Now this is a complete circuit.
Doctor,
So, yes.
could you be slowly a little bit because we are using one device? Go and come back to check.
Okay.
Yes, thank you.
Now this circuit is connected. Now what you need, you will take multimeter. You will search multimeter. Take it here, multimeter. And as you are aware that multimeter can measure ampere, voltage, resistance. So currently we need ampere. Okay. So we take wire. We connect one to the at this point. Okay. And second one is this one. Okay. Now. So now you
Doctor,
can check.
voltage or ampere?
Sorry,
Voltage or ampere?
I'm not getting.
The mode for the multimeter.
Yes.
Voltage.
No, no, no. First, we will find out the equivalent resistance for these resistor. So I connected on this resistance. You can find out voltage, but voltage will be applicable when you have some supply. Currently, this have only resistance. Okay. So now this is the resistance, and if we start simulation, you will check the equivalent resistance of this circuit is 1.56 kilo ohm. Okay, so here what you need, you will need to find 1.56 kilo ohm. Okay, and if you check manually also means by simple this simple law that R2 R3 in series, so 5 plus 2, 5 plus 2 7, and 1 by 2 plus 1 by 7. If you go and check 1 by 2 plus 1 by 7, you will get this value 1.555. So its equivalent resistance is 1.56. Okay. Now your first activity is complete. What you need, what you will do, you will just start simulation, send to, you download this image. Okay. You will download this image, and this image need to be pasted on your, you will get this image and just copy this image, copy and paste it here just. Okay, so it will be your first activity is completed, means this is the resistance type, and this ID you can put it on top where name and IDs are required here. Okay, so this one, now this is your output from TinkerCAD. So this is your activity. In this circuit, create the resistance circuit as shown in figure in TinkerCAD and measure
Doctor,
the equivalent. Yes,
could you go back please for a second?
this one.
Yes, 1 second. This is a multimeter, yes?
Yes, this is a multimeter.
Okay.
Okay, I'm giving you 2 minutes. Try by yourself. Okay, because now it is very simple.
Doctor, what do the numbers you use to just to understand the way you do it?
I just use the last three digit of my some ID. Okay, whatever ID you have. So let us suppose your last three digit of your ID is 156. So just take 6 as the first register, 5 as the second, and 1 is the third one. Simple of your ID. So all of your work will be different. Okay.
Doctor,
Yes.
Did I choose any number inside the multimeter or no?
No, multimeter will give you the equivalent resistance. How can you choose?
It's voltage, yes?
Resistance, it is resistance. Now,
Okay,
currently,
resistance. Then
دكتور
what I press?
this point here, it is start simulation at this point,
Where,
at the
doctor?
corner, right corner, right up corner, where
Okay.
my cursor is.
دكتور
Yes.
when I do start simulation
Hmm.
the millimeter read it M resistor.
Maybe your value is very small. Okay, what's your resistance is?
811.
811. I will check later once I finish all this part, then I will check. Okay, maybe you take
Okay.
in instead of ohms, kilo ohms, just check when you
Okay.
connected it is in kilo ohms or you selected milliohms. If you select bisolve milliohms, then the answer will be
We
in
should select what?
kilo ohms.
Kilo ohms?
Yes.
What is kilo ohms?
So just
Doctor, I
even if
can't change the kilo.
no, just go stop simulation. First go to the system, click on this resistance, select kilo ohms, and you can change the value. Just this, and instead of 2, type 5, it will be. Now see, earlier my equivalent registration is
The
1.56.
same,
Now,
doctor.
okay.
It is milli resistor.
Doctor,
Oh, okay. You change it to kilo ohms.
I change it.
Yeah. Then,
It is giving me the same answer.
so check all three. Okay. And at
Okay.
last we will check. Okay. Okay. Now move. Yes.
Doctor,
Yes.
I must send this photo on Blackboard.
Not in Blackboard. You will find a file, this file in Blackboard. Okay.
What's the name of the file?
In your assignment, you will find assignment 4.
I must put this one in assignment 4. Huh? Okay.
Yes.
Doctor, I've not
Download.
found assignment 4.
It is on Blackboard. Just now I uploaded. Okay. You will find it in Blackboard.
Doctor,
Yes.
can you see my drawing? Like
I will check.
the last number 180. It's giving me 0 volt.
Not volt. Click on the resistance. You need to click on resistance. You need resistor R, not volt. Even if I go to volt, it will also give me 0 volt. Why? Because there is no power supply. Definitely it will give me 0. So
أقول
instead
لك
of click on this
أقول لك
multimeter.
طب كم تسوي الواجب؟
Okay.
أنا بدافني
Okay.
هذا يلا.
Please put your mic on
قال
mute
لي
mode.
أنا 54. قلت أنت ينيت شكلك. يلا خلني
Doctor,
برايك.
Yes.
could you check my please
خلني
last digit
يلا خلني بشوف أنا أروح الحين
53.
بخرب
Yes,
يلا.
طحنون.
العرياني مايكك مفتوح غدير.
Okay. Yes.
Doctor, can you see the shot?
Doctor, I don't have assignment 4. It's not shown for me.
On Blackboard it is not showing.
Yes, doctor.
Okay, I will check after this class. I will check. Okay, just see now what I am doing, and I will also upload this lecture. So after that, you can also check. And in the weekdays, weekends, if you find that you are not able, even if you are not able to do after that also, then we will connect it online and solve it again. Okay. So first, see
Doctor,
what happened. Yes,
can you see the shot?
which short?
The shot on Teams.
Short or chat?
Shot.
Okay, this one is yours.
Yes, doctor, but it didn't give me numbers.
This is not giving you number because what you have done, you connect negative and positive to the same terminal. Okay, your work, see, just give me, I think,
Doctor, may you check my work, please?
Tehnoon, you are, see, this is your work, na? I think I need to, the last one. Hamdan, it is right. And Muhammad Khalfan. Khalfan, see, what you have done, you connect this at this point. Okay, it is not required at this point, but what is happening? Okay, this point, see, this point is not right. You need to connect it to this point. Okay, then it will
Oh, okay,
be
doctor.
okay. Without wasting, just go to the power supply, which is the main part of today's lecture. Okay, so see what it is written in the second activity. You have to connect it to the AC supply. Build the above circuit, this circuit, because this part you already built. Build the above circuit using the breadboard. The input circle of these Vin comes from the function
Doctor,
generator. We will use function generator. Yes,
doctor,
as a
there's a student, he cannot enter the class because his laptop is broken. He make for me a phone. He's trying from half an hour. And now from the phone, he cannot enter this link.
I don't know. No one is coming in the lobby. If someone will come, I will allow him. Okay. Share him and then whose mic is not working. Okay. Okay, yes, Tanun, now you can unmute yourself. First see
Yes,
this problem.
doctor.
First see this problem, then we will take the question after that. Okay, just stop everyone. So we use function generator and sine wave. So signal type is sine wave. Amplitude is the last digit of your number. So last digit amplitude, my last digit is 2. So I will take 2 volts. Frequency is 10 times. So frequency is 20 and offset is 0. Okay, now this circuit, and now we have to make this circuit only. Okay, so in TinkerCAD this is already made. Now we need only this part. Okay, so here you will go to function generator. If you write function,
Doctor,
yes,
yes. Doctor, this is which assignment?
assignment 4.
We already finished this, right?
No,
No. Which one we finished before the
3.
lesson before? Three. Three, yeah?
Yes. So now the function generator's frequency is 20. Last, it is based upon your last digit. Okay, so if your last digit of your ID is 10, then take is 10 and 100. Okay, now this happen. Now what you need to connect it this to positive. Okay, and take black as, now your circuit is complete, just positive and negative. And if you start simulation, it will give that. Okay, one more thing, if you go to the voltage, okay, see, voltage will change. Why voltage will change every time? Because it is a AC supply, sinusoidal supply. So supply is changing, so its value also change with time. Because frequency is very less, it means time period is very high. That's why it is changing very slow. Okay. So now once it will be finished, so same you have to do. You have to download this image, send to download this image and paste it on. Okay. Copy this image and need to paste it here. Okay. This is your write the equation of your circle. Equation of the circle, if you go to your module, you will find that equation of this is Vt is 2 sine 2 pi ft plus Vdc. So here amplitude you know, frequency you know, time period will depend upon the frequency. So just put it as t, and Vdc is 0 because there is no offset. So this equation you can put it here, and according to the amplitude and frequency you can take value here. Okay, so now this part is completed. Okay, what is happening? Display your output signal at oscilloscope. Now we need oscilloscope by connecting V0 to the circuit R3. Now we need to connect a oscilloscope at this point R3. See at this point. So in TinkerCAD, where is our first? Go to the oscilloscope. Okay, oscilloscope, put it here. Now what you need? You need to put it across R3. R3 is this. So R3 means start point of R3 is this and end point any of this point. So what we will go? We will connect this is the end point, and sorry, start point is this one. Okay. Okay. So oscilloscope is connected to R3C from starting to end point. Okay. Now again start simulation. So you can check that this signal, this cycle is very short, means within 1 second there are more number of cycle, there are number of cycles. So what we can do, if we decrease its time, then definitely if we decrease its time, less number of cycle is come. So at this point 100 milliseconds, so in case of 100 millisecond just put it 50. Okay, if we put it 50 and check, if stop simulation 50 millisecond. Now see, for 50 millisecond there are how many cycle? 1, 2, 3, 4, around many. So we can also change it. Stop simulation 25. Okay, now see, there are only 1, 2, 3, 4. Okay, or you can reduce more by changing its time. Okay, if there are only one line or something, then increase the time, then you can see its value. Okay, so what it is showing, what it is asking, next question, display the output signal oscillo V0 by this. Okay, adjust the oscilloscope to view 2 or 3 cycles. So we can adjust the oscilloscope. Okay, and you can also just take the screenshot now at this point and paste it here, because it is showing the output voltage. And how you can measure the voltage here? Just check amplitude. Amplitude, it is connecting approximately 1 square, 2 square, 2.8 times, around 2.8, and one division is 0.1 volt. Why 0.1 volt? Because total there are 10 volts. It is showing from here to here it is 1 volt, and these boxes are 10. So one box has 0.1 volt. So 0.1, 0.2 and 0.8, around 0.8. So it is 0.28. Okay. And if you go and check this, this will also give you the values. Okay. It will change and see 243 means 0.243, negative of 0.243. Now it is in between somewhere. Then it will going to positive. So it is also changing, but it is depend upon the whole circuit. We are concerned of this. So you can find out the amplitude, time cycle, frequency. How you can check the frequency? Frequency is the inverse of the one time cycle. Time cycle is complete cycle. If you start from this point, go again and this till this point. So how many square it is covering? Only two squares. Okay. So two squares and one square is 25 millisecond because it is total is 250. One is 25 millisecond. 25 into 2, 50 millisecond is the time cycle. And 50 millisecond, if you divide by 1 by 150, you will get the frequency as 20 hertz. Okay. So here you will just need to paste and write. Okay. Calculate the output value VP across the Kirchhoff law and Ohm's law. This you can do, just check the slide. Okay. Now the third part, you just need it to square signal. Square amplitude, you just need, it is a mistake, it is 10 actually. From 0 to 10 it is -1, from minus amplitude is 2. Okay. Frequency is total is 120. 120 means 1 divided by 20 millisecond means 0.2, which is equals to 5 hertz. Okay. And VDC, there is offset. Yes, there is offset because actually it should be from 2 to -2, but it is 1 from -3. It means offset of -1. Okay. Now,
Doctor,
yes,
for some reason, you see the when we use the
oscilloscope,
oscilloscope, yes,
oscilloscope,
for some
yes.
reason I only have a straight line.
Because I told you why, because it is a straight line, either it is not connected or your time period, this time period 50 millisecond, it is very much less. See,
How much? How much I make
if
it?
I make it microsecond, 20 microsecond, see only one line. So change it to millisecond, check what's it's happening, or even if it is in millisecond, multiply it 4 times, 5 times, then check. Okay.
And what
So
about the
what should I make it
function
exactly?
generator, doctor?
Sorry.
What about the function generator?
Function generator, you have to put it values. Okay, I will first I will also demonstrate about your square signal, then we will go with the problems. Okay, because just a minor change. What the minor change? You go to this from sine to just change to square. Okay, and amplitude to frequency 5. Frequency 5, amplitude 2, offset of -1. Okay, and start simulation. Okay, see now this will happening, only 2 cycle is coming. If I want to make more cycle, I will change to this 50. See if more cycles are coming. Okay, so again take the screenshot from here and just paste it on this part. Okay, so this is all about your assignment in steps. Now I will take question one by one. Okay, just tell me where you are saving. Yes.
Yes. We do this يعني after we take photo and we post it on lab assignment 4 huh?
Yes.
Yes. So we don't do anything in the other paper, right?
I didn't get me your word. Please, once you tell, put your mic
I
off.
said like we don't do anything on the other paper, right?
No, on other paper not. Please mute then. Not other paper. You will find a file on Blackboard. Okay, as a assignment 4. There you need this. You will find this file. You have to fill this and submit it again. This is just like a worksheet. Okay, and also if you do work on TinkerCAD, I will cross check your file and TinkerCAD file. Okay. Next question.
Doctor, may you
We don't
repeat
do anything,
please?
Sorry.
Step 2. The second step. May you repeat it, please?
Which second step? Can you tell me?
For,
Sine
for,
wave
for the generator.
generator. Okay. This is your function generator. Okay. In function generator, what you need to select sine wave. Offset is 0. Amplitude is your last digit number. Let us suppose your last digit number of your ID is 4 and frequency is 10 times, that is 40. Okay, just this need and start simulation. Okay.
Doctor,
Yes.
could you please wait a few seconds till we draw the lines, then we will see
Yeah,
steps by
sure.
step the number. Wait, please.
Okay. Any other question?